For most of human history, humanity believed something that felt completely obvious. We believed we were standing at the center of everything, and honestly, from our perspective, why wouldn't we? Look up at the night sky. The sun rises in the east and sets in the west. The moon drifts overhead. Stars move across the heavens. Everything appears to revolve around us. To ancient civilizations, the universe looked like a giant cosmic machine turning around Earth itself, and for thousands of years, that idea shaped reality. Philosophers argued it, religions embraced it, kings ruled beneath it. Entire civilizations built their understanding of existence around a simple assumption: we are the center. But history has a habit of humiliating certainty. Over centuries, humanity began discovering something uncomfortable. Earth wasn't the center of the solar system. The sun wasn't the center of the galaxy. Our galaxy wasn't unique. And eventually we learned that the observable universe contains not thousands, not millions, but potentially trillions of galaxies. Every discovery pushed us farther away from the center, farther from significance, farther from cosmic importance, until science arrived at a profound conclusion: we are probably not special. And that idea became so successful, so powerful, that modern cosmology quietly built itself around it. Today, one of the deepest assumptions in science is called the Copernican Principle. The idea that humanity occupies no special place in the universe, no preferred position, no preferred location, no preferred direction. The universe should look statistically similar no matter where you stand. No cosmic center, no hidden arrow, no giant structure pointing somewhere across reality itself. And for decades, everything seemed fine, until scientists looked into the oldest light in existence and found something they were never supposed to see. A strange alignment, a giant cosmic pattern, an invisible direction stretching across the universe. Eventually, researchers gave it a name so dramatic that people assumed it had to be fake: the axis of evil. And if this strange anomaly turns out to be real, it could mean one of humanity's deepest assumptions about reality is incomplete, or worse, wrong. To understand why this discovery made cosmologists uncomfortable, we first need to understand what exactly the Copernican Principle is. Because despite sounding complicated, the idea itself is surprisingly simple. Centuries ago, astronomer Nicholas Copernicus challenged a belief that had dominated civilization. Earth was not the center of the solar system. At the time, this wasn't just science, it was philosophy, it was religion, it was humanity's place in existence. Copernicus proposed something radical. The Earth moves. Earth orbited the sun. Eventually, history proved him right. But over time, scientists extended this idea far beyond the solar system. If Earth isn't special, then maybe our location in the universe isn't special either. Maybe no place is special. This eventually evolved into one of modern cosmology's most important assumptions. The universe is homogeneous and isotropic. Homogeneous means matter is distributed roughly the same everywhere on large scales. Isotropic means the universe appears roughly the same in every direction. Imagine floating billions of light years away. According to standard cosmology, your view should not be fundamentally different from ours. No preferred directions, no giant arrows, no hidden orientation, just random structure spread across an expanding universe. This assumption became incredibly useful, because without it, modern cosmology becomes brutally difficult. Many equations that describe the universe rely on this symmetry. Remove that assumption, and reality suddenly becomes much harder to predict. But assumptions only survive as long as observations support them. And eventually, scientists discovered a way to test this idea directly, by looking backward in time itself. If you could travel backward far enough, past galaxies, past stars, past planets, you would eventually arrive at a universe that looked nothing like the one we see today. Nearly 14 billion years ago, everything was different. Temperatures were unimaginable. Matter and radiation existed inside an enormous cosmic fog. The universe was so dense that light itself couldn't travel freely. Photons constantly slammed into particles. Space was opaque. No stars, no galaxies, no darkness, just blinding chaos. Then something changed. As the universe expanded, it cooled. Eventually, temperatures dropped enough for electrons and protons to combine. Suddenly, the fog vanished. Light was finally released. Ancient photons escaped and began a journey across the universe. Those same photons still exist today, right now, passing through Earth, passing through your body, filling every direction in space. This ancient radiation became known as the cosmic microwave background, the afterglow of creation itself, the oldest light humanity has ever seen. Scientists realized something incredible. If the early universe truly followed our cosmological assumptions, that ancient light should preserve evidence, like a fossil, a snapshot of infancy, a record of what reality looked like billions of years ago. And hidden inside that ancient light, they found a mystery. In 1964, two radio astronomers named Arno Penzias and Robert Wilson encountered a problem. No matter where they pointed their antenna, they kept detecting static. Not ordinary static. Something strange. A faint background signal seemed to come equally from every direction. At first, they suspected equipment failure. They checked electronics, calibration systems, atmospheric interference. They even cleaned pigeon droppings from inside the antenna. Seriously. They removed birds, removed debris, checked everything. Yet the signal remained. Eventually, they realized something extraordinary. They had accidentally discovered the oldest light in the universe, the afterglow of the Big Bang itself. At first glance, it appeared nearly perfect, uniform, smooth, exactly what cosmologists expected. But eventually, technology improved. Researchers started examining tiny fluctuations hidden inside the signal, differences measured in millionths of a degree, and buried within those tiny variations, something strange began appearing, something that should not have existed. To understand what happened next, we need to talk briefly about something called multipoles. Don't worry. This sounds much more terrifying than it actually is. Scientists break complex patterns into mathematical components. Think of music. A song can be separated into frequencies. Cosmic maps work similarly. Researchers deconstruct the microwave background into giant wave patterns, large structures, smaller structures, and increasingly fine details. Among these structures are something called the quadrupole and octupole moments, huge wave patterns stretching across enormous portions of the observable universe. Normally, these patterns should point randomly. No preferred orientation, no giant alignment, no meaningful direction. Instead, researchers noticed something strange. The quadrupole and octupole appeared aligned, not perfectly, but enough to make scientists pause, enough to create discomfort, enough to spark arguments. Because suddenly, the oldest light in existence appeared to contain a preferred direction. A giant arrow. Something modern cosmology said should not exist. And eventually this anomaly earned a nickname, the Axis of Evil. The name sounds like something from a conspiracy documentary, but it came from scientists themselves, partly as a joke, partly because of how deeply uncomfortable the discovery was, because if this alignment turned out to be real, it threatened assumptions sitting beneath modern cosmology itself. Suddenly, strange questions emerged. Could the universe rotate? Could reality have structure on scales larger than expected? Could inflation be incomplete? Could the early universe have evolved differently than we imagined? Or maybe something even stranger? Maybe our observations were wrong. Maybe contamination from nearby galaxies distorted the signal. Maybe dust inside our own Milky Way was interfering with measurements. Maybe statistical coincidence created patterns where none truly existed. And there was another problem, a huge one. We only have one universe. Think about that. In most sciences, experiments can be repeated. You test results, you gather new samples, you compare outcomes. Cosmology doesn't get that luxury. There are no backup universes, no alternate reality laboratories, no second observable universe for comparison. We have one sky, one dataset, one chance. Scientists call this cosmic variance. Sometimes strange patterns emerge purely by chance. If you flip enough coins, eventually you'll get unlikely streaks. Maybe the axis of evil was simply the universe rolling cosmic dice. Maybe we just happened to observe something statistically weird. Researchers continued investigating. Then came satellites like WMAP and later Planck. Their job was simple: map the cosmic microwave background with incredible precision. And strangely, the anomaly refused to disappear. Again and again, researchers found hints of alignment. Not enough to declare a revolution, not enough to rewrite textbooks, but enough to keep people uncomfortable, enough to keep asking questions. And perhaps that's what makes this mystery fascinating. Scientists didn't ignore it. They didn't bury it. They didn't declare the issue solved because it felt inconvenient. They attacked it. Repeatedly. Because real science behaves differently than pseudoscience. Pseudoscience protects assumptions. Science tries to destroy them. Scientists actively search for evidence that their ideas might be wrong. And if reality survives those attacks, confidence grows. But if reality refuses to cooperate, new discoveries emerge. History has seen this before. Tiny anomalies once appeared in planetary motion. Later, they helped reveal relativity. Small inconsistencies in physics eventually transformed our understanding of the universe itself. Sometimes revolutions begin as tiny statistical oddities, not with certainty, not with headlines, but with whispers. Maybe the axis of evil eventually disappears. Maybe future observations reveal contamination. Maybe it was coincidence all along. Science has seen mysteries evaporate before, but maybe not, because somewhere buried inside the oldest light in existence, inside tiny fluctuations left behind from creation itself, the universe may be trying to tell us something. For centuries, humanity kept learning the same lesson. You are not the center. You are not special. You are ordinary. But if reality itself truly has a preferred direction, then perhaps the universe never finished its story. And somewhere beyond the limits of our understanding, the cosmos may already be pointing toward an answer.